Hello. Okay, there's only a couple people here. We have to wait a few minutes for people to enter the class. Okay, people are starting. Okay, people are starting to enter in. There's a new homework assignment. We'll start off today by talking about the homework assignment. Then we're going to start talking about events. Okay, so I'm going to wait a little bit while everybody comes in. About half people are here so far. Okay. Okay. Okay, let's go ahead and start. It seems like quite a few people are here. Okay, there's a first homework assignment. If you click on this link, then on this page is the assignments listed. And okay, here's the explanation of the assignment. Okay, you need to read this explanation. The assignment's actually in this zip file. Let me download the zip file and unzip it. This is a homework assignment about graphics. You have to draw something. Now we're going to start talking today about event-driven programming, and your next programming assignment will be using event-driven programming. This one is just a program where you can using Java to draw things. And what you have to do is you have to create this panel. This panel will draw something. See, it's got this paint component method. The paint component method, this code here draws something. Okay. And this code here, you'll have to write this program. You have to write a constructor for this class, and you have to write this method for this class. Okay. Now, what you have to do is you have to write code that draws pictures like this. Okay. So here's some sample pictures of what you have to draw. Okay. Okay. What this is a program. When you pop it up, it just paints a picture where there's this background of a checkerboard. And then the drawing has these randomly placed circles, and inside the circles is another drawing. So there's like two background drawings. There's two background drawings, a checkerboard and this kind of fractal-like drawing. The checkerboard is outside the circles, and this drawing is inside the circle. If you notice that this is actually one continuous image, and the circles let you see that background through the circles. The circles are randomly chosen centers and diameters, and they're not supposed to be overlapping. So you have to write code that generates these circles, make sure that they're not overlapping, draws the checkerboard in the background, draws the circle, then fills in the inside the circle with this other background pattern. Okay, now a lot of this is explained here. Okay, so a lot of what I'm talking about, I'm just saying is explained here in words. Okay, here's a sample program here that shows you how that funny looking background, this funny looking background image in here, it's an example program right here that draws it. So if you take this program and compile it and run it, it draws that background image. Okay, see, there's the background. And that's the background that's, if you actually put these on top of each other, you'll see that this is exactly this. See, you're seeing, see here, you're seeing through this thing to this thing down here. Okay, yeah, so this is what you see, you see through the circles, this pattern here. Okay, this pattern here is drawn by one line of code, actually. It's this line of code here. Okay, what it is at every point in this, at every in a graphic system, remember, there's this window is made up of pixels. And the other day we magnified the pixels. Okay, let me magnify them again. I found a better program for magnifying pixels. This thing doesn't, this program handles the modern desktop properly. So this one works better than the other one did. Okay, so let me magnify 16 times. Okay, so see there's this image is just made up of little pixels. Each pixel is one square, okay? And the code the pixels start over here in the upper left-hand corner at 0, 0, okay? Right now, see this position here? It's giving me coordinates. Those are the coordinates on my desktop. So my mouse pointer now, see, upper left-hand corner is 0, 0. See, I'm going towards 0, 0 in the upper left-hand corner. See, I'm at position 0, 4 now, okay? Now, if I want, I can have this program show me the position I am in a window. So if I right-click here and, let's see, show, where is it? Oh, I forgot where it is now. I can have it tell me the window position, not the. No, I don't see it now. Okay. In this window, this pixel here is 0, 0. And this window is 1,000 pixels across by 500 pixels down. So this pixel down here is pixel, the X coordinate is 1,000 and the Y coordinate is 500. Zeros up here, positive X goes this way, positive Y goes this way. Every pixel on this screen has its own color. Okay, when I go like here, you don't see the pixels very well because there's not much difference in the color from one pixel to the next. Here you see the pixels real clearly. Each little square on the left is one pixel. This program iterates through all the pixels. So it writes a nested for loop where I goes across from 0 to the X dimension, J goes from 0 to the Y dimension. So the I coordinate is going across the screen. The J coordinate is going down a column. So the I coordinate is a row and the J coordinate is a column. So this goes across a row from 0 to the X width, and J goes from down a column from 0 to the Y height. Okay, X width and Y height. And then for every one of these IJ coordinates, it computes a color. The color is computed by this funny thing. It takes the I integer and the J integer and exclusive ORs them together, and then just takes that value mod 255, because the largest value a shade of color can have is 255. There's only 255 shades of a color. So you OR the I and J together. Now, the funny thing is when you OR I and J together, you get this kind of interesting pattern. So this is you take the I and you take what coordinate you are this way, what coordinate you are this way. That gives you a pair IJ. You take the I and the J, you OR them together, and then you use that as the RGB color. Notice it's a grayscale, so I'm using the same RGB color. Use that as a color, and you get this pretty pattern. Okay, you get this interesting little pattern. Doesn't have a name as far as I know. It's kind of a famous pattern. I don't think anyone's ever given it a name, but it's the pattern you get when you OR the horizontal and the vertical coordinate of the pixels together, and then use the ORed value as the color, the shade of gray, then you get this pattern here. Okay, now that's the pattern that's going to be shown inside the circles. And what you would do is you would modify this loop so that if you take your I and J, then you have to write code that determines, is I and J inside of a circle? If I and J is inside of a circle, like here in this example, if I and J is inside one of the randomly chosen circles, then you paint that pattern. If I and J is outside of a circle, you don't draw anything, you just leave the background color. So you have to write this code that builds this scene here. Okay, and it's a static image. Your program, every time you run it, is just going to draw one picture. The picture doesn't change, it just draws one picture. Okay, so here's 4 different samples of what the picture might look like. These are different. Yeah, see these are 4 different samples of what the picture might look like. Every time you run the program, your code should pick random centers and random radiuses. That gives the program random circles. Okay? Now that's done in the constructor of the code. Okay? That'll be done here in the constructor. The constructor will, this part right here, generate the random data about the circles and their centers and make sure that they're not overlapping. You need to write code to store that data in some variables. So you'll need to add some instance variables up here. You'll need new instance variables, arrays, to hold the radiuses and X and Y coordinates of the circles that you generate down here. Okay. Then later on, so the constructor will get called first and generate the circles. Then after that is done, then the GUI system will call the paint component method and ask this code to paint the circles. So it's a 2-step process. Generate this data here, paint the data here. But this generates the data only for the circles. This paints everything. So this will paint the background image, then it'll paint the circles, then it'll paint the interior of the circles. So it'll be essentially a 3-step process. Actually, in theory, you could paint the background up here if you wanted to, but it's not, no, actually don't do it that way. Yeah. So in the paint component method, you have to do everything in the paint component method. There'll be 3 steps to this. Paint the background, the checkerboard pattern, draw the circles on top of the checkerboard, then draw the interior of the circles on top of the checkerboard. So you'll draw the checkerboard, then draw the blue circles, then draw the interior of the circles. Okay. And when you draw the interior of the circles, you'll be using just that line of code there, or those 2 lines of code there. For the I and J, you'll order the I and J coordinates together and then create a color using that shade of gray. And then, here's how you draw 1 pixel in Java. You draw a line that starts and ends at the same place. This is a quirk of Java. There is no draw pixel method. You draw a pixel by drawing a line and saying where the line starts and have the line end at the same place it starts. Okay, so if you look up the draw line method, like in the homework assignment, I give you links to a lot of these methods. So here's the draw line method. Normally, the draw line method would draw a line from x1, y1 to x2, y2. Okay, draw a line using the current color. See, that's why you set the color. Set the color to be the color of the you want for that pixel. Then draw using the current color. So the set color method sets the current color. After you set the color, you'll draw a line from x1, y1 to x2, y2, except that x1, y1 and x2, y2 will be the same point. So you draw a line starting and ending at the same point. That will paint 1 pixel. That will let you paint 1 single pixel, these different colors. Okay, that's how you get different shades of gray at different pixels inside this circle. Okay, every pixel's got its own IJ coordinate, and you use the IJ coordinate of a pixel to decide the color of this thing here. Now, the checkerboard pattern is each square is 100 pixels wide and 100 pixels tall. So this is a 100 pixel by 100 pixel square of one color, 100 pixel by 100 pixel square of another color. You need to know what these colors are. And if you look in right here where it says the RGB value, there's what that color is. Okay, 255, 189, 96. So that tells you what that color is. There's what that color is. 192R, 56G, 14 blue. And this little, see this border here, that color is 84, 129, 30. Now, if you zoom around in here, let me set something here. See that little box there? That box is the pixel that this thing down here is telling me the color of. So whatever pixel's in that box, is the pixel that gets the color shown down here. So if I go over here, you can see how as I move the mouse around, the little box is showing different shades of gray. Okay, those different pixel value, those different RGB values, notice that they're all the same color. Notice the RGB in these shades of gray, RGB are, this is 186, 186, 186. Here it's 172, 172, 172. Those three numbers came from this line of code here. You see that? So the RGB are set the same. Okay. So when you move around in here, you're seeing the result of ORing together the I coordinate, the J coordinate of that pixel. Okay. All right. So this is what you'll do. You'll do this computation inside of the circles. Outside of the circles, you'll just draw these squares. Okay. The squares can be drawn a number of different ways. So for example, in Java's library, there is a draw rectangle method. You give it the upper left-hand corner of a rectangle and the width and height of a rectangle, and it'll draw the rectangle in whatever is the current color. Well, actually, no, I'm sorry, this draws a rectangle. You want actually to draw a filled-in rectangle, so you'll want the method, not this one, to draw a filled-in rectangle, you want this method. I closed the window. You want draw filled-in rectangle. This draws in a filled-in rectangle. Okay, so it uses the current color to fill in a rectangle that has an upper left-hand corner here and width and height here. Okay, so you could draw the background, the checkerboard, by drawing a rectangle here, a rectangle here, a rectangle here, a rectangle here. You can also draw the background using the similar kind of idea that this program uses here. You could just write nested for loops that iterate over all the pixels and just pick the right color to paint on each pixel. You can do it. You can draw the checkerboard many different ways. You know, you can draw it by square, 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 or you can just draw it by going across the first row of pixels. There'll be 100 pixels of one color, 100 pixels another color, 100 pixels another color. Then you just draw the next row. You can do it row by row also. Just whatever way you think is easiest for drawing the checkerboard. Fill the panel. The paint component method will fill the panel with the checkerboard. Then the paint component method will fill the panel with the circles that were computed in the constructor. And then the paint component method will fill in the circles with this other pattern. Now, one thing that's important about this is, why do we compute the circles in the constructor, not down here? Why not just in this method compute the circles and then draw them? When you run this program, you can minimize, like this is not the program, this is just a picture of the program, but when you run the program, you can minimize the window and maximize the window. You know, so you can do things like minimize the window, maximize the window. When you do that, the window needs to be redrawn. The window isn't remembered. Okay, that's why you have this paint component method. The paint component method is called whenever the window needs to be redrawn. If you recomputed the circles every time you painted the panel, you would get different circles in different places each time you, if you minimize this and then maximized it, you'd get a different picture. Then if you minimized it and maximized it, you'd get a different picture. We don't want that. We want there to be the same picture. So the circles need to be generated one time and then saved. So that's what the job of the constructor is. This is typical of a lot of graphics programs. The constructor computes what the picture should look like. The paint method then paints it. The paint method paints it when it needs to be repainted. Usually, there's two things that would make it need to be repainted. One thing would be changing its size, but in this program, you're not going to do that. That'll be the next homework assignment. So this thing's never going to change its size. It's going to be fixed in size. but it will need to be redrawn if you minimize it and maximize it. That will need to make it be repainted. It doesn't need to be repainted if you cover it up and uncover. We did that. We showed that the other day with some examples. If you cover a window up and then uncover it, that does not make it be repainted. The Windows operating system keeps track of what's there. And if you move a window around, that also does not make it need to be repainted. What makes it be repainted is changing its size. Like that window's actually being repainted right now, but that's in this paint map. There's this program here. This is just a screenshot of the Java program. So this is the IRFan view program. Right now, IRFan view is redrawing its window every time I change its size, and it needs to redraw it every time I maximize it. But IRFan view is drawing it from the data stored on the hard drive. IRFan view, when it redraws this program, it just goes back over here and reads it off of the file on the hard drive. Your program is going to, when it starts up, it will compute the data that's going to draw. And then every time it needs to redraw it, the paint method will redraw it from the data computed in the constructor. Okay, so it's not a lot of code you have to write, but like a lot of these homework assignments, you have to understand what's going on. So you need to look at the examples we did in class, and real importantly, read this description. The description describes more or less the steps you have to do. It points you to the methods you should be using. Okay, your program here's the driver program. This is not the executable program. This is the program that runs, and all this program does is instantiate that paint panel. So it instantiates instantiates that panel. This number 45 says how many circles there are. So the number of circles is a parameter to this panel. 45 is a nice number of circles. So if these examples here have 45 circles on them. Okay. So all this program does is it will, actually I can run it here, but it won't do anything. You can compile it and run it. Okay. Right now it instantiates an empty frame. Okay, because the paint method isn't doing anything yet. So it's instantiating a 1000 by 500 pixel empty frame. Okay, so you won't modify this program. This program just instantiates the frame. There's the panel. It instantiates the panel, the frame holding the panel. This thing instantiates a J frame. See, it instantiates a J frame holding the panel. Okay, then this is the code for painting the panel. Well, for initializing the panel in the constructor, then painting the panel in the paint component method. Okay, and this is how we do graphics in Java. Yeah, if a program uses the constructor, a panel will use its constructor to compute things that don't change ever. Okay, or to generate initial values for things. Some programs don't need a constructor because every time they're painted, they might paint something random, but that's pretty unusual. It's pretty unusual for a program to paint something completely random every time you draw it. Okay, but so it's pretty common to have a constructor that initializes what should be drawn, and then the paint method draws from that initial data. It might update that. Now, this program doesn't ever update that data. That'll be the next homework assignment. The next homework assignment, you also will update that data by mouse clicks and things like that. So right now, once this data is generated, nothing changes. The program will just draw a static image just like this. It'll just draw a static image for the point of the program is just to draw that image. Okay, draw one of these randomly selected images like this. Okay, so in this program, once the data has been generated, the paint method just repaints the data over and over again. There's no updating of the data. That'll be the next assignment, where the data will somehow get updated. With the next assignment, what you'll be doing is you'll allow someone to drag these, like click on a circle and drag it around. Then the program, instead of just popping up a window and just that's it, then the idea of the program will be that you could click on one of these circles and drag it around, and as it drags, you'll see what's underneath it, so to speak, changing. So you'll think of these as like little windows. These circles will be like little windows to the background image. So that'll be the next version of this assignment. You'll click on one of these and drag it around, okay? But right now, the program just draws it statically, okay? So you write, this program's written for you. It just, it pops the window up for us. So there's not much to this, so you don't need to change this. All your work will be in this constructor here and in this paint method here, okay? And you need this example to see the idea of how to get that background image. And also just the idea, see, this is a paint component method too. See, here's an example of a paint component method. This paint component method just paints this one static image. This is an example of a paint component painting. Now, see, there's the static image. If I cover it up and let me show you, remind you again how you know when it's being called. Let's give this static method a little toString method, okay? So let's just say, okay, so this method will print a dot each time it gets called. Okay, notice I got called 2 times. Covering it up and uncovering it does not make it get called. See, it's not being called. The paint method is not being called. But if I minimize it and then maximize it, see, the paint method got called 2 times. I'm not sure why. I'm not sure why it got called 2 times, but the paint method got called 2 more times. Okay, now, dragging it around does not cause the paint method to get called. Covering it up and uncovering it up, covering it up and uncovering it doesn't cause the paint method to get called. You can shove it outside the edge. You can shove it all, outside and bring it back. Oh, actually, no, that did cause it to get repainted. What I did here is I dragged it to my other monitor. When I dragged it to my other monitor, it got repainted. That's interesting. If I drag it over here, that doesn't cause repaint. Oh, yeah, it is. Yeah. See, when it goes off the edge of the screen, it does need to get repainted. Okay. You can see better if we did this the other day, if we make this print out a counter. The dots are hard to see. Okay. So if I push it over here, see, it's being repainted. What about the bottom edge? Yeah, being repainted. Okay. But if I just cover it up and uncover it, cover it up and uncover it, see, that doesn't cause it to be repainted. Okay. If I drag it to my other monitor and drag it back, it gets repainted. And if I minimize it, when I maximize it, it needs to be repainted. So minimize it and then see, maximize it, it needs to be repainted when it's redrawn. Okay, so here there's no data. So this simple demo program, there's no constructor that needs to be called. Okay. Here's the paint panel. It's called background panel. The constructor there is a constructor, it just sets the size of the panel, but it doesn't initialize any data. It sets the size of the panel, but it doesn't initialize any data. Because every time you draw the panel, it draws the exact same image, and it can compute this image. It doesn't need to know anything to compute this image. In your homework assignment, you have to know where those circles are. So you have to compute ahead of time where all these circles are, what their center and radius is. So you need to compute that ahead of time in the constructor. So the homework assignment will need a constructor to compute that data, and then the paint method will draw it. And you'll need this code in your paint method in the homework assignment. You'll need a version of this code. Because you'll paint the background, then you'll paint the circles, then you'll paint what's inside the circles. So you'll draw a 3-step process: draw the background, draw the circles, draw what's inside of them. And when you draw what's inside of them, you have to use the data that was generated when the program was constructed, when the panel was constructed. That it would be really weird if you didn't use, if you generated the data in the paint method. What would happen is that every time somebody did this, the program would just, the circles would be jumping all over the place. Because every time the thing needed to be repainted, you would get a different image. Like here, remember that thing is being repainted over and over again. See, you don't see it, but this thing's being repainted all over and over again. Okay, this thing was being repainted over and over again, but it happens, the computer's fast enough that you don't see the repainting happen. Okay, but it's being repainted, but the data is the same each time, so it doesn't need a constructor to compute the data ahead of time. Okay, all right, let me think. Any question about the homework assignment? Can I go through it? You have to read it carefully, and we'll go over this again on Wednesday. So between now and Wednesday, look this over and see if you have any questions. But does anybody have any question like right now? Is any question come up right now? Anything? These are the methods in the Java graphics library that might be useful to you. Okay. This is the graphics class. So this is the page for the graph. It's long. Okay. You don't need to read too much of this. The methods from the graphics class you'll need are set color, draw line, draw oval. Draw oval will draw the circles. Draw rectangle will draw the squares. So the only method you'll need is and draw a line you use to draw a pixel. By using the trick of drawing a line starting and ending at the same place, you can draw a pixel. So you set color sets the color that things are being drawn in, whether it's a pixel, a circle, or a rectangle. Draw line will let you draw one single pixel. Draw oval and fill oval will let you draw circles. Draw rectangle and fill rectangle let you draw squares. And those are all in the graphics class. Then you'll need colors. So here's the color class. There's some colors predefined for you. And if you need to generate your own color, there is the color constructor. So about the only thing you need from the color class is this constructor, which takes an RGB value and gives you a color with that much red, that much green, that much blue. And those RGB values come from here. See, the RGB values that this color constructor takes is exactly the RGB values that this program is showing you down here. See, it shows whenever you hover over a pixel, it shows, see, that's a reddish pixel. So the RGB is a high number for red, a low number for green, and a low number for blue. Okay. If I move to a bluish pixel, it's hard to move. Well, oh, there's a solid blue pixel. See, R is very low, green is medium high, and blue is very high. These numbers are between 0 and 255. So blue is 223. So that's almost maximum. This is a greenish blue because it's got a medium amount of green in it, and it's got almost no red in it. Okay. Here's another shade of blue that's also got about an equal amount of green and blue in it, and a little bit of red in it too. So it's got some red, some green, and some blue. Here's an orangish color. Okay. The orangish color is a lot of red, a little bit of a medium amount of green, and a very little bit of blue. Okay, a lot of red, a little bit of green, and very little blue gives you this kind of orangish shade here. Okay, white is full amount of red, full amount of green, full amount of blue. So 255, 255, 255. And black is, well, real solid. Let's see if I can find solid black. Solid black is 0, 0, 0. I'm not finding a solid. Let's see. There's a solid black, 0, 0, 0. Okay, so these letters are written in solid black. Okay, so there, that little square is over. So solid black is 0, 0, 0. Solid white is 255, 255, 255. And all your other colors are something in between. Like this border here is kind of a lightish blue. Okay, notice it's actually, it's almost gray. So the red, green, and blue are pretty close to this. It's actually kind of a bluish gray. And notice that the blue color is the largest, 219. So it's red, green, blue, RGB. The blue color is the slightly largest, but it's a pretty much, they're pretty close to each other. So that's kind of a bluish shade of gray. Okay, when the RGB are equal, you have a shade of gray. So if you find the RGB equal, then you get that's exactly a shade of gray. And here's a green. See if I can land on a green. There's a green pixel. See, R is 0, G is 128. So there's no red, no blue, and it's like a light green because there's no red, no blue, but green is 128, not 255. So that pixel right now is a light green. Okay, so you construct a color in Java by calling the color constructor with the RGB you want, and you can match any color you need to. So like you can go to the homework assignment. You can hover over any one of these pixels and you get the RGB value for that color, for that square. You get the RGB value for that color of that square. And you get the RGB value for that border around the circle. There's the RGB value for it. And these you compute. So these RGB values, again, they're computed using the I and J coordinates of each point. So you need 3 fixed RGB. You need that color, and that color. You need that yellowish color, that reddish color, and that bluish color. You need those 3 colors, and then these will all be computed on the fly. Okay, so you use the color constructor to construct the color, and you use the set color method in the graphics class to set what is the current drawing color. So you pass it a color object, and it makes that the current color to draw with. Whether you're drawing a pixel, a rectangle, or an oval, you would draw it in the current color. Okay, so there's the, oh, and you'll need the random class to generate random numbers for the set. When you want these randomly chosen centers and radiuses, you need to use a random number generator and the next int method. And in the code, I actually already instantiated the random number generator for you. No, did I? Yeah, right here. I'm sorry. See, there I instantiated the random number generator for you. So it's already instantiated. So there's the random number generator object. And then you get random numbers from it by calling the next int method. Okay, so I already instantiated the random number generator. You just need to use it to generate random x and y coordinates and random x and y coordinates and random radiuses. Okay, and your x and y coordinates should be within this window. So your x and y coordinates should stay within the dimensions of the window. So there's the window's 1,000 pixels across and 500 pixels tall. And there's a maximum radius and a minimum radius for the circles. So the maximum radius is 175 and the minimum radius is 30. So you need to generate random numbers for radiuses between 30 and 175. And this is the thickness of this circle here. The little blue circle is 6 pixels wide. And it tells in in the description of the homework assignment, it tells you how to get a 6-pixel wide circle. Okay, so read in here for an explanation of how to get a 6-pixel wide circle. Okay, any question? Okay. If you've never written code that draws things, this will take a little getting used to. Yeah. But these methods in the graphics class are the methods that draw things. You have these, what we sometimes call primitives. The primitives you're given are draw a line, which draws a pixel, draw an oval or fill in an oval, draw a rectangle or fill in a rectangle. Those are your primitives. Those are the things you can build pictures out of: dots, lines, and circles and squares. Okay, a lot of graphics is drawn by just dots, lines, circles, and squares. And this homework assignment, that's pretty much what it is. It's a combination of circles, squares, and then this pattern in here, you do it dot by dot. There's no lines in here. You're not going to draw any lines in this program, but you need to build this pattern up dot by dot. So you'll use, because Java doesn't have a set pixel method, the quirk is you use draw a line with the beginning and end point the same to paint a pixel. So you'll paint these dot by dot. You'll draw squares up here and you'll draw a circle here. Okay, so that's those are what we call the primitives, the graphics primitives that we can use. Okay, circles, circle, pixels, lines, circles, and squares. Those are the most basic primitives. And then as you get more advanced into graphics, there are more advanced primitives, but the starting point are dots, lines, circles, and squares. Okay, and different colors. Of course, doing them in different colors, you can think of color as one of your primitives also. You have these different colors. And then you have to call these methods in the right order to draw these pictures. Okay, so it's kind of fun programming. The internet's full of graphics. People are doing graphics all over the place. Anytime you see an animation on the web, pretty much everything you see, I mean, even this is a graphics. All this is just, this is just a combination of nothing but circles, lines, squares, pixels. The letters are actually drawn pixel by pixel. When somebody wants to draw a letter, that's what a font is. A font just is what pixels to turn on for each one of these letters. So letters tend to be drawn using the pixel by pixel method. But for example, there's a square here, circles here. You can see that there's circles and squares all over the place that are just, these various primitives. Oh, notice how this square is rounded. See how that square is it's not really a square. It's not really an oval either. That primitive is in the graphics class. So you don't need it for this homework assignment, but one of the primitives they give you. So if you look up methods, there is a, see if I can remember where it is. Draw a round rectangle. Okay. See, this will draw a rectangle with rounded corners. A round cornered rectangle. That would be used, for example, to draw this address bar up here. This address bar is a rectangle with rounded corners. So that's this primitive, draw a round rectangle. Okay. So, I mean, that's a slightly more advanced primitive, but Java gives it to you. It gives you the ability to draw rounded rectangles. Okay. So if you look around, if you look at this, what you're seeing, like this slider is just a rectangle that moves. Okay. So everything, if you look, most of what you see on the screen is circles, ovals, squares. Yeah. And so these primitives these basic primitives will take you very far. Points, lines, circles, and squares, and rounded squares can get you really far in terms of primitives. And then another primitive that Java has that's a little bit more advanced is you can draw arbitrary polygons. So there is draw a polygon. So if you wanted to draw a pentagon or a hexagon, you can actually tell it to draw an arbitrary. You need an array of points, and it'll connect the dots in those points. So you can draw pretty sophisticated polygon shapes too. So these are the graphics primitives that Java gives you that you can use to build up to paint on the screen. You can paint things using these basic graphics primitives. For this homework assignment, you only need these. You don't need anything other than those. So you need dot, oval, and rectangle. You don't need line. The draw line, remember, is just there so that you can draw a dot, a pixel, by having the line start and end at the same place. Okay. That turns out to be not an unusual trick. Graphics libraries, a lot of times, instead of having a draw a pixel, will just say, well, if you want to draw a pixel, just draw a line that starts and ends at the same place. So having a draw line double up as draw a pixel is not an unusual little trick in a graphics library. Okay, any question about this stuff?
Just worried about once I start doing this and writing the program, we might find a bit difficulties with like we should go what, and this, this kind of seems a bit hard.
No.
What do you think?
Pardon me, say again?
Yeah. So when we are doing the assignment, do we have any other documentation that we can refer as well? Do we have, can we refer to any tutorials online? Will that help?
There is
well?
this chapter on graphics. There is 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 this chapter on graphics. Okay. So, those are the standard references. Those, they explain things. Okay. Now, whenever you write a program, you have to start somewhere. In this assignment, where are you going to start? What's going to be the first thing you try to do in this assignment?
Could it be loading the background image first?
Yeah, draw the checkerboard first. Get that drawn. Get the checkerboard drawn.
Right.
Then generate the random circles and try to draw them next.
Okay.
Then fill in the dots inside. So so just like any other program, you're not going to write the whole program at once. It would be real hard to say, I'm going to write this program and then compile it and it's going to run. That would be impossible.
Right.
So what you're going to do, I would say, draw that background checkerboard pattern first. Okay. Then, and that will be code. You'll put that code in the paint component method. So put in the paint component method the checkerboard. Then go back to the constructor and generate the data for the random circles. Then when you have random circles, go down here and put the draw the random circles. Don't fill them in, just draw them. Just draw the random circles on top of the checkerboard. Is the checkerboard still there? Yeah, just draw the circles on top of the checkerboard. Get that. So get the checkerboard, then get the circles on top of the checkerboard. Then lastly, go in and fill in these. You're only going to end up writing about 100. You're going to write well under 100 lines of code. Well under 100, probably like 50 or 60 lines of code. Not a whole lot of code. Not going to write a whole lot, but do it in steps. Generate the checkerboard. In the the checkerboard will go in the paint method. Then go back up to the constructor and generate random circles and radiuses, 45 of them, so that they don't overlap. Then after you have those circles, go back down here and draw the circles on top of the checkerboard. And then lastly, fill in the checkerboard, fill in the circles with their with this pattern here. And then that last step will be where you'll steal this loop from here. Basically, you'll steal this loop and just say, before you draw the pixel, you'll just ask, is this pixel inside of a circle or not? So you'll wrap this in an if statement that says, if this pixel is inside of a circle, draw it. If it's not inside of a circle, don't draw it. Okay, and you'll have your circles in an array, so you'll have to iterate through the array to find if the pixel's inside of one of the circles. So you'll have to take that pixel and test it against each one of the circles to see if it's inside one of them. If it's inside any one of them, you draw it. Okay, so and if you do it in steps, each step is doable. Yeah, altogether you're going to be writing like somewhere between 50 and 100 lines of code, but you should build it up in steps. Okay, and we've done some examples in class, and like I said, there's all these examples. These all have example programs in them. So there's plenty of examples in here of drawing using these primitives, like drawing squares. Okay. So we've had these have been up there for for 2 weeks now. This is the background information besides what we've been doing in class. These are pretty good. These are pretty good explanations. In particular, you're interested in these two in particular. Let me close these. The two you're most interested in, or should be most interested in, are this one, two-dimensional graphics, and graphics 2D. This is specifically about graphics. This assignment doesn't involve anything with event handling or components. There's no drop-down lists and checkboxes. So you're interested in just graphics here. Okay, so this one is an explanation of graphics, and this one is an explanation of two-dimensional graphics. So those would be two good places to start. Okay. Okay. And then this is also a whole another. This one also is about just graphics. See, 2D graphics. No event handling here. No drop-down lists or check boxes or buttons. Just drawing with shapes. You know, just drawing with shapes. Though they put a lot of emphasis on using pictures. So if you read this, there's a lot of emphasis about to them. The graphics includes pictures. You're not using pictures here. We're doing everything by pixels. We're not loading pictures like this. Okay, so we're doing things like this: drawing and see circle, square, polygon, circle, square, polygon. That's what we're interested in: the ability to draw circles, squares, and polygons. Actually, in our case, just circles and squares. Circles and squares is all we need to draw here. Okay. So you need to read. You know, you're not going to write programs in a vacuum. Yeah, so you have to. There's a fair amount of reading that needs to go in to be able to get ready to write the code. But I think everything you need would be in these references here. Okay, and then the code examples we did in class. We've been doing some examples in class. So look at the examples we've done. We've done some graphics programming in the examples in these folders here. Okay. Okay. What do you think? Any other question about this assignment? And yeah, we'll go back over it again on Wednesday. So if you have, look it over by Wednesday. If you have more questions, we can go over more questions on Wednesday. Anybody else have another question? Any other question? Okay. What we're going to do today, okay, let's see. What else we're going to do today is start talking about events. Okay, so here's a folder with some code in it about events. We've talked about components and we've talked about graphics. Events start letting us put actions into things. We've drawn things like buttons and drop-down lists, but we haven't done anything with them. And in this homework assignment, you're going to draw a picture, but it's going to be a static picture. There's going to be no interaction with it. It's just going to be like this. The picture will just pop up and just be static, just like this one too is. This one here, once it pops up, it's static. There's no interaction with it. Okay, so this thing got drawn. Notice I can't even change the size of it. Notice how, see how like that window can be changed, and you can see how my mouse changes when I get to the edge, and I can if you look at this window, it can't be changed. And that's where your homework assignment is going to be. It's very non-interactive. In the code, that was this method call here, set resizable false. See, I'm saying to Java, I want this window to be fixed. Yeah, it can be dragged around, but it's very non-interactive. You can't click. There's nothing that happens if you click on it. You're not even allowed to change its size. See, when I hover the mouse on the edge, unlike these, see how the mouse changes? The mouse changes shape to let you know you can drag that edge. The mouse changes shape to let you know you can drag that corner. Okay. This one, the mouse doesn't change when you get towards the edge because it's not an adjustable window. Okay, it's a fixed window. Some windows, like, see that window, oh no, that window's draggable. Now notice that window's only draggable this way. See how that window's not draggable? I can't drag it down. Okay, so this window is only adjustable in one direction. Now, this window is unadjustable. See, when I hover over any corner, this is an example of a window. It can be dragged around, but you cannot change its size in any way. So that's like our homework assignment. It's a window just like this one. It's not resizable. So if you pay attention to GUIs, you'll see all kinds of windows. This window is not resizable. This one is horizontally resizable, but not vertically resizable. And this one is resizable in any way. Okay. And we'll eventually get to do all those things in our Java programs. We'll control the resizability of a window. But for the homework assignment, the window is not going to be interactive. So the window is going to be completely fixed. Now, let's start talking about now. It takes events to resize a window. What happens is I do something with my mouse, and that tells the program that something's happened with the mouse. The program does not own the mouse. So the operating system will tell the program that the mouse did something over its window. Now let's look at an example of this. Here's a program called watch events. If you compile this program and run it, it's a GUI Java program, pops up several windows. This program lets you watch what's happening with events in Java. Okay, so the program's got 3 panels. This panel is going to let me see information. This panel is where I'm going to, this is the actual GUI panel where I can do things. And this panel here lets me decide what events I want to watch. Okay, so for example, if I press on that button, I don't see anything happening over here. Buttons create what are called action events. If I turn on the action event, then when I click a button, see, I see a message over here. That's the event handler. I turned on the event handler for this button. So now I can see that when I click a button, I get an action event. Now, if I turn off action event and turn on item event, clicking a button doesn't generate item events. Item events come from drop-down lists. See, drop-down, each kind of GUI component has its own notion of what an event is. So item events come from drop-down lists. Okay, now I can clear this window over here. Now I'm going to turn on action event. Action event comes from the button, but it also comes from a drop-down list. See, the drop-down list generates both action events and item events. This is the way Java designed their GUI system. So a drop-down list, if I turn on both action and item events, if I click on here, I got 3 events. I got, and the print's pretty small, but I got item event and I got 2 item events and an action event. Okay. This program, what this program does is it lets you see the events. And the minute we'll talk about how you write code for these events. This is letting us see the events. What this means is that I can write a program that responds to this button. I can write a program that responds to this drop-down list. But what I have to know is that in the world of Java, if if I want to respond to a button, what I have to do is somehow use an action event. Action events are how I respond to buttons. If I want to respond to a drop-down list, I need to use action and item events. The action event tells me one thing, the item event tells me something else. Okay, what about the checkbox? Okay, now if I turn off all events, the checkbox isn't going to do anything. Okay, what about action event? Okay, the checkbox is giving me action events. What about item event? Checkbox is also giving me item events. So the checkbox gives me both action and item events. So if I check this box, I get 2 events. Now, Java was designed to give you a lot of control over how your program behaves. What they're doing is they're giving you 2 pieces of information about checking the box. You know, and it's kind of quirky that there would be 2 events to check. You do one thing, click on that box, and you get 2 different events. And when you write programs in Java using checkboxes, it's just up to you to decide, do I want to use the action event or do I want to use the item event that came out of the checkbox, or can I make use of both of them? Now, not many people use Java these days. Most people are going to do this stuff using JavaScript and HTML, but JavaScript and HTML are very similar. You could write a program very much like this in JavaScript and HTML and watch what happens when somebody uses a checkbox or a button or a combo box. Okay. Now let's look at it. There's another kind of thing here. There's this scroll bar. Scroll bar lets you slide. It's a real tiny scroll bar. The scroll bar lets you slide back and forth. Okay. That's not an action event. It's not an item event. It's not going to be a text event because it's not a text item. It's what's called an adjustment event. Okay. So see, sliding back and forth is its own event. It's something called an adjustment event. It includes also clicking on these little boxes at the end. So if you click on the little boxes at the end, each time you click on the box, you get 1 event. If you grab the slider and slide it, you get a bunch of events. Okay, so sliders are called adjustment events in Java. Okay. Now, these are what we call high-level events. They're tied to these components. Oh, here's the text item. So if I want a text event, see, like right now, I'm typing into that window, but nothing's happening. But if I turn on text events, see, every time I type, I get an event over here. So as somebody's typing, your program will get events letting you know that somebody typed into your text box. Now, what about action event? Does typing? Notice typing does not generate an action event. Typing does not generate an item event. Typing doesn't generate scroll events. Typing, in this case, only generates text events. Okay, all right, so these are what they mean by high-level events is the events are tied to specific components. Buttons generate action events, drop-down lists generate action and item events, checkboxes generate action events, a text window generates text events. Over here are low-level events. Low-level events are to do with the mouse and the keyboard. Okay, like here, I'll turn on a mouse event. Notice that now when my mouse enters and leaves this area here, I get mouse events. See, enter, leave, enter. Notice that I'm only getting events now when I enter and leave. Now, I'm not even pressing down on the mouse. I'm just moving the mouse over this area. If I press down on the mouse, then I get an event. Okay, so I entered this area, press down on the mouse, release the mouse, press down the mouse, drag the mouse. Oh, when I drag the mouse, I don't get any events. If I want to drag the mouse and get events, I turn on this other event, mouse event motion. Okay. See, now when I move the mouse around, see, I'm getting Now just notice the mouse moves in, and now the mouse motion gives me events. This other one gave me events. Notice now there's no events happening. The events when I enter and leave, enter, leave, enter, click, unclick, leave, enter. So mouse event is entering and leaving, pressing and releasing the mouse, but not moving the mouse around. Mouse event, this mouse event motion is separate. It's moving the mouse around, and it distinguishes between whether the mouse is up or mouse is down. Like right now, I'm mouse down, now I'm mouse up. Now I'm mouse down. See, notice that in the window on the left, it says mouse dragged. That's the mouse down. That's called mouse dragging. This is the mouse up. That's just called mouse moving. Okay. So in your programs, you want to know, you can write code that, like in the next homework assignment, I told you that the next homework assignment, you'll be clicking on one of these circles and dragging it around. Okay. You'll use these events. We'll learn more about these events, and you'll see that you'll be able to use these events to do that. See, here I'm just moving the mouse, but I don't have the mouse down. So I can distinguish between the mouse moving when the mouse is not being clicked and the mouse being clicked. I just click the mouse. Now I'm dragging the mouse. If you're on a computer at home, please download this stuff and play with it. Get a feel for what these things are doing. Okay. Right now, we're not looking at any code. We're just looking at a real high level of what the events are, not what the code for them is. Okay. Now, over here, this thing has a bunch of tabs. Right now, we're looking at all the events. Let me turn off. If I want to emphasize that button, I go to the button tab. Now, notice that the button only gives you action events. See here, when I was on the event tabs, I'm looking at everything. When I go to this tab, I'm only looking at the button. The button doesn't give me item events, text events, or adjustment events. It only gives me action events. On your hand, the combo box gives me action events and item events. Okay, now here's the button. Now, what I would like to know is, can I tell when the mouse is over the button? So I turn on mouse event, and then see when now I'm being told that, oh, your mouse is over the button. It hasn't clicked on the button, but it's over the button. So your program can know if somebody just slides over a button. Yeah, that's different than somebody clicking on the button. See, the clicking on the button generates one kind of event. Just rolling over the button generates a different kind of event. Your program knows everything. The computer knows where the mouse is all the time. The computer owns the mouse. The computer knows exactly where the mouse is over time, and the computer can tell your program where the mouse is. This is used all the time by websites. When you go to a web page, okay, the New York Times now knows I moused over that graph. They know it. They recorded it. I'm just, my mouse is just kind of wandering around. They know my mouse was over that picture. They know that. My computer sent that. I guarantee that my computer sent that information back to them because they want to know what stories on their page get looked at. Like if I click on a story, they know I clicked on it. But what they also want to know is, did I even just maybe click on that story? Did I maybe click on that picture? Was I scrolling down and looking at these pictures and these stories? They can tell that by what we're seeing here. They can tell that you hovered over something. Okay, so just the fact my button can know that something hovered over it, that the mouse hovered over it, even if I never clicked on it. Okay, if I go here to the J combo box, it's the same thing. Okay, let me turn off this for the button. Go back. Okay, now right now I'm not asking to know if my, like here I'm asking if somebody is clicking on the combo box. Okay, so I'm asking, is somebody clicking on it? Is somebody interacting with it? But what if I want to know if somebody just hovered over it? Well, then I would turn on this mouse event. Now I know, oh, look, the mouse is just over that. Yeah. I don't care about the scroll bar and the checkbox, but right now, if my combo box wants to know that it was even hovered over, it can know that. Usually something like a combo box doesn't want to know that it's just hovered over. Usually it doesn't want to know the low level events. Usually it just wants to know the high level events. Usually it just wants to know, oh, you clicked on the item. Okay. So notice that this, oh, notice how this didn't generate any events yet? Because I haven't picked anything yet. The high level event is to, oh, look here. See, notice I'm reselecting the selected item. If I select a different item, I get two events because I unselected one and did select another. But see, these are high level events. They're tied to specific things I do. If I just drop that list down and don't do anything, there's no high level event yet. But if I go down here to mouse event, now I get mouse event. Oh, I didn't get a mouse event for that. Oh, Java's not letting me know that this thing was clicked on. I thought I would get through it. I thought, yeah, see, I can tell that the mouse hovered over this thing. But if I want to know that this thing was clicked on, I'm not finding that out. I thought I was going to get that from a mouse event, but the mouse event is not being passed to my program. Even though there's a mouse event there, it's not being passed to my program. Okay. If I turn on mouse events for the panel, see now, oh no. Oh, this guy's absorbing the mouse event. Some components can absorb an event and not propagate it. So what we're seeing here is that the mouse event on this component is being absorbed by the component, not being passed around to the program. Okay. That's kind of interesting that this guy absorbs I forgot that happened. This guy's absorbing the mouse event. Okay. What about the checkbox? Let's see if the checkbox does something similar. Okay. Okay. Now, if I turn on mouse event, I can tell that I hovered over the checkbox. See, so now I'm being told I hovered over the checkbox. Okay. Well, the only thing I can do on the checkbox is check it. But, oh yeah, see, I don't have the action item, so I'm getting mouse events now. So I am getting mouse events from the checkbox. Then if I turn on these guys, I'm getting, in addition to mouse events, I'm getting, see how many, like what? When I click on this checkbox, see how many events I got? Because I got the action event, the item event, and the mouse event. I got all of those, okay? This guy was kind of quirky. The combo box is interesting because the combo box absorbs the mouse events. The checkbox did not absorb the mouse events, but the combo box is. So I have to check on these guys to know that the combo box, and see here, nothing, the combo box is still not doing anything, and it doesn't do anything until I go down inside. It isn't until I go in here that the combo box gives me any events. Okay, a program like this is how programmers figure out what their programs can and can't respond to. See, here I'm finding out in a really low level what I can and can't find out about a checkbox or a combo box or a checkbox. Okay. So let's look at another one. Look at the scroll. Let's look at the scroll bar. Here's the scroll bar. Scroll bar only takes adjustment events. But what about mouse events? Okay. See, I'm hovering over the scroll bar, so I'm getting mouse events. Notice when I click on these guys over here, I don't get any mouse events. What about if I tried that other mouse event? This guy's doing like the combo box. It's absorbing the clicking. See, I'm not getting the mouse, I'm not getting mouse events from clicking there. But I get mouse events from, yeah. Now I do get mouse dragged events. See, I'm getting mouse dragged events. And then if I turn this on, I'll get both mouse dragged events and adjustment events. So now I'll get, if you look over on the left, you'll see it alternating mouse event, adjust event, mouse dragged, mouse, you get adjustment events and mouse events alternating. The adjustment event is a high level event from the component, and the mouse event's a low level event coming from the fact that the mouse is dragging back and forth over that thing. Yeah. Usually on a scroll bar, you wouldn't want to know about the mouse event. You'd want to know about the adjustment event. Usually, yeah, not always, but most of the time, you would only want to know about the scroll bar. You wouldn't want to know about how the mouse is going back and forth over it. Okay. So this program lets us watch how this program lets us see what's available to us as events. Okay, then we're running out of time. What we're going to do on Wednesday is look at how do you hook into these events? What kind of code hooks into these events? How does a program ask to know about where the mouse clicked? And how does it respond to where the mouse clicked? This is called event handling. It's very tricky stuff. On the one hand, it's real easy to mimic event handling. On the other hand, it's real hard to understand event handling. So we're going to try and work on it in both ways. We'll look a little bit about just mimicking it. You copy people's code and you can get programs to work. But then at the more subtle level, you want to actually understand how the event handling works. A lot of programmers don't really understand event handling that well, and they end up writing buggy code. But you can write code that works, maybe a little bit buggy, but you can write code that works if you don't understand how event handlers truly work. But so there's, on the one hand, just getting something to work, and then on the other hand, there's understanding the subtlety of event handling. So we'll start looking at that on Wednesday. There's a whole bunch of, in this zip file, this event zip file, there's a whole bunch of code in here that shows a bunch of different aspects of event handling. And the references for event handling are these explanations for event handling are in these chapters here. All these chapters explain the basics of event handling. Okay, so basics of event handling are explained in there, and we'll look at code examples in this folder. Lots of code examples. If you open this folder, some of these subfolders have, this has got like 15 different programming examples. This one's got another 15 programming. There's a whole bunch of different ways. Events are kind of subtle. So there's if you pick up 5 books on how to handle events, you could see 5 completely non-overlapping ways of handling events. What one book tells you can be completely different than what another book tells you, because there's so many different ways of handling events. Okay, so we'll look more detailed at these examples of event handling on Wednesday. Okay. Any last questions? Any last questions?
When is the deadline for the
we'll meet again on Wednesday. Bye.